All right, everybody, good morning and happy Monday. So, for today's lesson, we're just going to take one more day on systems of equations. Um, when we learned it in school, we started with graphing first. And I just wanted to come back and finish up with graphing just to try to stamp the concept of what exactly it means for something to be a solution to a system of equations. Because in our live conference on Wednesday, um, we didn't seem to really remember entirely, so we're just going to spend a little bit of time practicing visualizing what it means with graphing here. So to find a system of equations with graphing, we have just some basic steps here that we're going to use. We just graph both equations. If they cross, the solution is the coordinate where the lines intersect. And then we write our answer as an ordered pair. But what does the solution mean exactly? So the solution to a system, again, a system of equations, we should remember. We learned this last week. We learned this in school in January. A system of equations, system equals two or more equations. And a solution makes all the equations true. So for a linear equation, and this is just a little reminder of getting into polynomials later this week, x to the first is linear. So for linear equations, x to the first or y to the first. And you're always going to see either x or y in an equation. That makes it linear, a linear equation. There are three options. Those three options that we're going to work on today are the lines intersect. There's one solution. The lines are parallel. There's no solution. And the lines are the same or they coincide. That's infinite solutions. So for one solution, what we're looking for is the lines have different, I'm going to put m for slope. Same slope, different b for y-intercept. So if the lines have one solution, they have a different slope. Because if they have a different slope, they're eventually going to meet. If one is going like this and the other is going like this, they will eventually intersect. If the lines have the same slope, but they start at a different point, they will go forever and they will never meet, like these lines right here. And the third option is same slope, same b. I could put same line as well, because in that situation, they're also the same line. If there's just one line, there are infinite solutions, because think about it. If I have two equations that are exactly the same equation, anything that makes one of them true is going to make the other one true. If I have two equations that when we graph them look like this, nothing is going to make both of these equations true. Right here, x is 0, y is about 2. That doesn't make this equation true. Any x and y value I take off of the top line won't make the bottom line true. And right here, on this graph, the first graph, the only point that would make them both true is this value. It looks like it'd be something like x is 3, y is 3, but who knows, because there's no numbers on the graph. I'm just guessing. So that basic idea of if they intersect once, there's one solution, and that solution is the point that makes all equations true. We'd write that as an ordered pair. If they are parallel, there's no solution, and if they coincide, if they're the same line, there's infinitely many. And infinitely many, again, would mean that both equations are actually the same. That's what we're looking for there. So let's take a little bit of time here. Go ahead and pause and try to figure out what is the solution. Remember to write it as a x and a y value. Drink some coffee here. So again, let's find our x value first here. We go 1, 2, 3 over, so our x value is 3, and we are 1 from the x-intercept, or from the x-axis, sorry. So -1. We went down 1 from the x-axis and over 3 from the y-axis. So our x value is 1, 2, 3, and our y value is -1. And what that means is the point x is 3, y is -1 makes this solution true. So on this one, real quick, name the solution. Go ahead and pause. I'm going to give you 10 seconds here, pause, or try to figure out the solution. So you guys might have seen here, we have x goes over 1, 2, so our x value is 2, and our y value is 1. So these are not too difficult here. On the homework assignment, I'm going to model a couple questions in just a minute. We're going to graph the lines, then find the solution in IXL. So one more right here. Let's find our x and our y value. Okay, so our x value is, we go back 1, 2, -2. And my y value is 1, 2, 3, 4, -4. -2 and -4 is what we should have gotten. So once we have the lines graphed, finding the solution is really easy. We are going to practice here graphing the equations. So on this IXL assignment you guys are going to do later, y equals -x minus 5. So we did this the other day, right? This is my y-intercept, -5. And then I go down 1 over 1 because the number in front of x is -1 or -1 over 1. So I've graphed my first line. My second line, -1 is my y-axis. I have to select the line down here, -x minus 1. -1 is my y-axis. And again, I go -1 over 1 is my slope. So they're both graphed now. -x minus 5, -1 over 1, they are parallel. Or they have the same slope, but a different y-intercept. So there is no solution. And we would submit that. We get positive affirmation. We did wonderful, guys. Our next one here. Let's graph this line. My y-intercept is -5 because that's my b. My slope is up 4 over 5. Up 4 over 5. My next line, the green line, my y-intercept is +4 and my y-intercept is down 1 over 1. So right here, x is 5, y is -1. We have one solution. It's x is 5, y is -1. So this is a pretty easy IXL here. Just remembering how to know the number of solutions. You guys can find the solution, but knowing the number of solutions, graphing them real quick. The green line, the orange line, x is -3. We have down 1 over 4. And the y-intercept is -9, down 1 over 4. They are again parallel, so there is no solution. So this should be a pretty easy IXL for us. Just wanted to cement the concept of what does the solution mean, what does the number of solutions mean visually again. So we worked more algebraically last week. I just wanted to again cement that concept visually. Please email me if you have any questions. Thank you all very much and have a great